concentrated solar thermal energy, or CST. Huge promise, right? But the tech itself can often be pretty complex, maybe costly too.
Exactly. Yeah, and that complexity, that cost, it's kind of a barrier, which is why this new development we're looking at today is so interesting. It's from a research team over at IIT Madras.
IIT Madras, okay.
Yeah, led by Mr. Adithyan TR, Professor Sreeram K. Kalpathy, and Professor Tiju Thomas. They're in the Metallurgical and Materials Engineering department. And, for listeners wanting to get the key info quickly, this innovation they've come up with, it could be a really significant shift, a potential game changer.
A game changer, huh? Okay. Because they've created a low-cost heliostat. Is that right?
That's it. A low-cost, dual-axis tilt-roll heliostat.
Wow.
Designed specifically for smaller setups.
Dual-axis tilt-roll. Okay.
And crucially, it manages to avoid needing those complex, often expensive microcontrollers.
Right. Okay. Let's unpack that a bit. First off, maybe a quick refresher. What exactly does a heliostat do?
Sure. So think of a heliostat basically as a smart mirror. Its job is to follow the sun across the sky.
Tracks the sun.
Exactly. And it reflects that sunlight, focuses onto a single point to concentrate all that heat, that thermal energy.
Got it. So this dual-axis tilt-roll mechanism, why is that the significant innovation here?
Well, that's the clever part, really. It means the mirror can move in two ways.
Yeah.
It tilts, up and down, and it also rolls side to side. This combination lets it track the sun's path very precisely all day long, much more accurately than, say, a fixed panel or a single-axis tracker.
Okay, precise tracking. Now, you mentioned avoiding microcontrollers. For people thinking about, the bottom line, how does getting rid of those cut the cost?
Right. Well, microcontrollers are like tiny computers, aren't they? They manage all the complex calculations and fine movements in, many high-end systems, but they and the software needed to run them add a fair bit to the cost.
Yeah.
So this design cleverly uses simpler linear drives instead. Think of it like maybe using a straightforward lever system instead of a really complicated set of motors and gearboxes.
Oh, I see. Simpler mechanics.
Exactly. Less complex, cheaper to make. So for the end user, that translates directly to a lower initial investment.
Makes sense. And apart from just the initial price tag, what are the other upsides, especially for, the smaller scale users you mentioned?
Well, that cost effectiveness is obviously huge for, say, individual homes or maybe educational institutions, community projects.
Places without massive budgets.
Precisely. And the system is also designed to be more compact, which is a bonus if you're dealing with limited space, like on urban rooftops. Plus, fewer complex moving parts generally means, less to go wrong. So you're likely looking at lower maintenance needs, potentially better reliability over the long run.
Less hassle, lower running costs, potentially. Okay, so they built this thing. Did they test it out? How did it perform?
They did. They ran initial tests right there on a rooftop at IIT Madras. The location was 13 degrees north, 80.22 east for context.
Huh?
And the results were actually really encouraging. The heliostat did its job, it tracked the sun reliably, and it concentrated the energy effectively onto the target.
That's great.
Yeah, and they noted that the tilt-roll mechanism itself provided good, stable reflection, which, as we said, is pretty crucial for this kind of tech.
Good stability. Okay, sounds promising. So what's next for the team? Are they looking to develop it further?
Definitely. They've got a few goals. One is to enhance those linear drives, make them even more responsive, more durable, ready for real-world conditions.
Right. Durability is key.
Absolutely. And another big one is improving its ability to handle wind. Wind load is always a challenge for these kinds of structures, so making it more stable in different weather conditions is important.
Makes sense. Anything else?
They're also looking into scalability. Could the same basic principles, this simpler approach, be potentially scaled up for maybe larger solar thermal applications down the line? It's an interesting question.
Yeah, starting small but thinking bigger. So zooming out then, what's the potential impact here? Why should our listener who wants the essentials really take note of this?
Well, I think the big picture here is accessibility. If this kind of low-cost, simplified heliostat proves successful and manufacturable,
It takes off.
Yeah, it could genuinely make concentrated solar thermal energy much more reachable, for a whole new range of users. We're talking individuals, schools, maybe remote communities that are off-grid.
Democratizing the tech, almost.
Kinda, yeah. Empowering more people to tap into clean solar heat, which obviously helps with sustainability goals and reduces reliance on fossil fuels. But the really neat thing, I think, is just the ingenuity, finding that simpler, potentially much cheaper way to achieve the same fundamental goal.
It really is that aha moment, isn't it? When a clever, back-to-basics solution turns out to be really effective.
Exactly. It's offering a more accessible pathway to harness solar thermal power. No complex bells and whistles, just focused engineering.
Okay, so to sum it up, IIT Madras researchers have developed a simplified, potentially much cheaper heliostat design using a tilt roll mechanism.
Yep, avoiding complex controllers.
Which could open the door for concentrated solar thermal energy for many smaller applications and users who were perhaps priced out before.
That's the core takeaway. It's a potentially very practical innovation.
Right. And that actually leaves me with a final thought for our listeners to maybe chew on. Considering the simplicity here and the potential cost savings from this kind of back-to-basics engineering, what other areas of technology might benefit from a similar approach, stripping away complexity to boost accessibility and affordability? Just something to ponder. Thanks for diving deep with us today.